Okay, gentlemen, we are continuing with our inequalities. We're going to do a rational. We may or may not have done this. I'm just going to do it one more time. So similar to our polynomials with our inequalities, we need to find our x-intercepts, our critical key numbers. Keep in mind with our x-intercepts, if it's a fraction, our x-intercepts, it is okay, right, to have 0 in a numerator. So when your numerator is 0, your fraction equals 0. So our x minus 1 will equal 0 when x is 1. So we have an x-intercept at 1. Because it's rational, we do need to worry about restrictions. We know that a fraction cannot have 0 in the denominator. That is a no. Then we would have a no solution. It would be undefined. So in this particular case, our denominator would equal 0 when x is a negative 1. And we cannot use a negative 1 because then our fraction would be undefined. Also keep in mind, because it's an inequality, you cannot multiply through by your denominator, right? The one rule with an inequality is if you multiply or divide both sides by a negative, you switch the inequality sign, and we do not know if that quantity of x plus 1 would be positive or negative. So you cannot get rid of your denominator. You cannot multiply out and clear out your denominator. So we're going to take those critical key values, that negative 1 and a positive 1. Positive 1 was an x-intercept. The negative 1 was a restriction. So I'm just going to kind of make this a solid line. Just remember that that was a restriction. And we're going to take those factors, just like we did with the polynomials, and put these on the left side. So we have that quantity of x plus 1, and we have that quantity of x minus 1. And we're going to figure out where they would be positive and where they would be negative. We know that the x plus 1 would go to 0 at a negative 1. And if I were to pick any number to the right, that quantity would be positive. Any number to the left, that quantity would be negative. The x minus 1 quantity, we know it would go to 0 if we were to plug in 1. If we choose any number for x to the right of 1, it would be positive. Any number to the left, it would be negative. We are dividing those two factors. So if we had two negatives, we know we would get a positive number. If we had a negative and a positive, we would get a negative number. And if we had two positive numbers, we would continue to get another positive number. We are looking for less than 0. Less than 0 means we're looking for a negative. We're also looking at equal to 0, which means we want to include the x-intercept. So our negative interval is right here. Our x-intercept is the 1. So in order to write that in our interval notation, any x that is in the interval from a negative 1 to 1, including the 1 and not including the negative 1, would make that quantity on the left either negative or equal to 0. So there is our final solution. Okay, let's look at another one of those. Similar type problem, just a little bit more factors. We have to do a little bit more work. The other one was already factored for us. But we need to find those critical key numbers. So the first thing, being rational, we want to first find our x-intercepts. And our x-intercepts are where that numerator is equal to 0. And then we're also going to want to find those restrictions. And those restrictions are where that denominator is equal to 0. So I'm first going to go through and I'm going to factor the top and factor the bottom, if we can. If we can't, then we know we could, if it's a quadratic, do quadratic formula. But we're going to first try to factor. So in the numerator, we can definitely factor out an x. That leaves us with a 2x squared plus 5x minus 7. And then that actually can still factor down. We have a 2x and an x and a 7 and a 1 and a plus and a minus. And that will give us that positive 5x in the middle. In the denominator, we can just do a quick factor. So that's a 3x and an x and a 4 and a 1, both positive. And we want that greater than 0. So in terms of our x-intercepts, where the numerator is equal to 0, we have 3 critical key numbers. We've got the x equal to 0, we have the x equal to a negative 7/2, and we have the x equal to 1. In terms of the restrictions, or where the denominator is equal to 0, we have x equal to a negative 4/3 and x equal to a negative 1. So we want to make sure that we do not include those two particular numbers in our final answer. But we are going to use them when we look at our number line, listed on our number line. So we have our negative 7/2 here. Making sure I'm putting these in order. We have a negative 4/3, then we would have a negative 1, then we would have 0, then we would have a positive 1. And these were my restrictions. So I'm going to make these solid just to remember that we want to make sure we don't include those, and I'm going to put dotted lines on these. And there's no particular reason, that's just me being me. And then we're going to list all of those factors on the far left side. So we have a factor of x here. We have a factor of 2x plus 7. We have a factor of x minus 1. We have a factor of 3x plus 4. And we have a factor of x plus 1. We're going to figure out where those various factors are positive and negative. So for the factor of x, sticking with Christmas colors here, the factor of x, we know it's going to go to 0 at 0. If I pick anything to the right, that factor will be positive. Anything to the left, that factor will be negative. The 2x plus 7, we know goes to 0 at a negative 7/2. I pick anything to the right, that factor is going to be positive. I pick anything to the left, that factor is going to be negative. X minus 1, we know is going to go to 0 at 1. I pick anything to the right, that factor is going to be positive. Any number to the left, that factor is going to be negative. For the 3x plus 4, it's going to go to 0 at a negative 4/3. I pick any number to the right, that factor is going to be positive. Anything to the left, that factor is going to be negative. X plus 1, I know it's going to go to 0 at a negative 1. Anything to the right, that factor will be positive. Anything to the left, that factor will be negative. We are looking for greater than 0. We are looking for the positive intervals. Well, I have 5 negatives multiplying and dividing those factors. So 5 negatives are going to give me a negative. 4 negatives and a positive is going to give me a positive. Here I would get a negative number. Here I would get a positive number. Here I would get a negative number. And here I would get a positive number. Greater than 0, as I said, we want the positive intervals, which are here, here, and here. It is not equal to 0, so we do not want to include x-intercepts, and we never include our restrictions. So we only need to include those positive intervals. So our final answer is going to be the negative 7/2 to the negative 4/3 in union with the negative 1 to 0 in union with the 1 off to infinity. Okay, let's move on here. So we're going to move on to number 9. On number 9, very similar. We have our rationals, but here now it's not a single fraction. So we have multiple fractions. So the very first thing we want to do is we want to make sure that we have a 0 on one side of our equation. So I'm going to bring everything over to the left. I have my 1 over x minus 2, my 1 over x minus 1, and minus the 1/6 greater than or equal to 0. Okay. We cannot, because of the inequality, we cannot multiply through and clear out our denominator. We have to get a common denominator and keep that common denominator. So our least common denominator is going to be the 6, the x minus 2, and the x minus, the x minus 1. And And on the left side, we know this needs a 6 and an x minus 1. So this needs the 6 and the x minus 1. The middle term needs the 6 and the x minus 2, which means this needs the 6 and the x minus 2. And the third fraction needs the x minus 1 and the x minus 2, which means the numerator needs the x minus 1 and the x minus 2. So I'm just going to start immediately multiplying that all out, our numerator. So we're going to have a 6x minus 6. We have a minus sign that's going to need to be distributed there. So I'm going to get a negative 6x and a plus 12. And then I have another negative there that I'm going to have to distribute. So I'm going to FOIL and then distribute. So I'm going to get an x squared. That's going to become negative. I'm going to get a minus 3x. That's going to switch to a plus 3x. And I'm going to get a plus 2. That's going to go to a minus 2 because of that subtraction sign that we're going to be distributing. We always combine like terms any opportunity that we can. So I'm going to have a negative x squared. These 6x's are going to cancel nicely. So we're just going to have a plus 3x. And then a negative 6 and 12 is a positive 6. And a positive 6 minus 2 is a positive 4. And I always prefer my first term to be positive. So I am actually going to take my numerator and think of that as a negative 1 times a positive x squared minus 3x minus 4, so that I can divide out that negative to the other side of the inequality, but I know anytime I multiply or divide both sides by a negative, I'm going to have to switch my inequality sign. So my new fraction is going to become x squared minus 3x minus 4 divided by that 6x minus 2, x minus 1, now less than or equal to 0, because I have divided out that negative, just because I wanted my x squared term to be positive. And if I do my final factoring in the numerator, that's an x minus 4 and an x plus 1 over the 6x minus 2, x minus 1. So with the rationals, we know that we need to figure out our x-intercepts, those critical key numbers, and when it's rational, that's where our numerator is equal to 0. So in this case, we have an x-intercept at 4 and an x-intercept at a negative 1. We also need to figure out our restrictions, and we know with a fraction, that's when our denominator is equal to 0. So we have a restriction at x equal to 2 and at x equal to a positive 1. So we want to make sure we do not use those two values in our final answer, but we are going to use them for our number line. So as we go through, we need to use all 4 of those. My number line here, I have my negative 1, I have my positive 1, I have my positive 2, and my positive 4. And the 2 was a restriction, and the 1 was a restriction. And then a 4 was an x-intercept, and the negative 1 was an x-intercept. And then I'm going to use all of those factors. So we have the factor of x minus 1, the factor of x minus 2. We have a constant of 6, so I don't need to worry about the constant, and it's a positive 6, so it's not going to change any signs. I have the factor of x plus 1 and the factor of x minus 4. So we want to figure out when those various factors are going to be positive or negative. X minus 1 is going to be positive to the right of 1, negative to the left of 1. X minus 2 is positive to the right of 2, negative to the left of 2. X plus 1 is positive to the right of a negative 1, negative to the left of the negative 1. And x minus 4 is positive to the right of 4, negative to the left of 4. We're multiplying and dividing all of those factors. So 4 negatives is going to give us a positive number. Here we would get a negative quotient. Here we would get a positive quotient, a negative quotient, and a positive quotient. And we changed the equation So our final equation over here now is that we are looking for less than 0 because we had divided out that negative. So we are looking for the negative intervals, and it's also equal to 0, so we want to make sure we include x-intercepts. So negative interval, we have a negative interval here, we have a negative interval here, we have an x-intercept at 4, and we have an x-intercept at a negative 1. So we need to make sure all of those are included when we write our interval. So our final answer should be the negative 1 to 1. We want to include the x-intercept, not include the restriction, as well as the interval from 2 to 4. We do not want to include 2, which was a restriction. We do want to include the 4, which was an x-intercept. And there is our final answer. Okay, let's move on to domain. We'll do one of these. Just going to do A. I will leave B for you. But with A, or just domain, keep in mind if you have an even root, what's inside of your even root. We know that this quantity has to be greater than or equal to 0. So whatever is inside here, whatever this quantity is, that quantity always has to be greater than or equal to 0 if we are doing an even root. Okay. Keep in mind on B, you have a fraction, so you are going to have to be careful about your denominator equaling 0. So on A, if I want to find the domain for 10A, I just need the quantity inside of that even root to be greater than or equal to 0. And now you're back at the very beginning few examples with polynomials and your inequalities. We know that factors to an x minus 5 and an x plus 1. Our critical key numbers are the 5 and the negative 1. I can do my quick little number line chart here, my sign chart. We had that factor of x minus 5 and that factor of x plus 1. We know the x minus 5 factor is positive to the right of 5, negative to the left of 5. The x plus 1 factor is positive to the right of a negative 1, negative to the left of a negative 1. You are multiplying those factors. So on the first column, we would get a positive number if we multiply two negatives. Here we would get a negative number. Here we would get a positive number. And we're looking for greater than or equal to 0. So we are looking for positive intervals, and we are looking for x-intercepts. So our positive intervals are here and here. Our x-intercepts were both the negative 1 and 5. All of those we want to make sure are included in our answer. So our positive interval is going from a negative infinity to a negative 1. Include that negative 1, and then we're going from 5 to infinity. Include the x-intercept at 5. And that is our final answer. Okay. I'm going to leave B for you guys to do. And do we have any more here? Oh, we have a couple more. Okay, so let's look at 11. So on 11, we will just set it up and then I will let you finish that one. On 11, you want to know for what values of B will the equation have real solutions. Well, keep in mind when you're talking about real solutions, that was when your discriminant, the b squared minus 4ac, either was greater than 0, b squared minus 4ac equal to 0, or b squared minus 4ac less than 0. Greater than 0 was 2 real solutions, equal to 0 was 1 real solution, and less than 0 was 0 real solutions. So we're just told real. We're not told 1, we're not told 2, we're just told real. So we need both greater than and equal to 0. So we want our discriminant of b squared minus 4ac to be greater than 0 for the 2 real solutions and equal to 0 for the 1 real solution. And if we identify A, B, and C on our equation, That's a b squared minus 4. Our a term is 1, the coefficient of x squared, and our c term is 1. And then I will let you finish that with your sign chart to figure out your solution of when that quantity is greater than 0. So I'm going to let you finish that. Okay, let's jump over to let's look at 13, and we will set up 13. I'm going to let you play around with 12, which is similar to what we have been doing. Okay, on 13, let me move this over here. You're given a piece of wire. That piece of wire is 12 centimeters long, and it's cut into 2 pieces. Okay, this whole thing was 12. And each of those pieces is put into a square. So I'm going to have one square. There's my second square. And the combined areas of those squares, we are told, exceed 5. We're trying to find values for x. Now you have a number of ways that you can set this up. I am actually going to call one side of my square, let me switch colors here. I'm going to call one side of my square, or one of my squares x, and I'm going to call my other square y. And if I took these 4 sides, that's one piece of my wire, and I take these 4 sides, that's going to be the other piece of my wire. So I know that 4x plus 4y is equal to 12, or I know that x plus y is equal to 3. And I'm also trying to find, for what values of x will the combined areas of those squares exceed 5. So if I go through and I find my area of this square is x squared. My area of this square, well, if x plus y is equal to 3, I know y is equal to 3 minus x. So if this is really 3 minus x, then the area of this square is 3 minus x, quantity squared. So I'm combining those, so I need to add those 2 areas. So x squared plus 3 minus x, quantity squared, and it has to exceed, which means it is going to be greater than that 5. So now we're back at the beginning where we have a polynomial with an inequality. So if we go through and simplify that, we have a x squared plus a 9 minus 6x plus x squared. We want to get 0 on one side, so I'm just going to immediately subtract over my 5, greater than 0. So I'm really looking at a 2x squared minus 6x plus 4. Oops, not equals. It's supposed to be greater than. Sorry about that. Greater than 0. And that, if I divide by 2, is going to be an x squared minus 3x plus 2, greater than 0. And we want to find those critical key numbers. So that factors to an x minus 2 and an x minus 1. So we have a key number at 2 and a key number at 1. And I'm just going to come over here on the side to my little chart, my sign chart, my plus minus chart. My factors were the x minus 2 and the x minus 1. And the x minus 2 is positive to the right of 2, negative to the left. My x minus 1 is positive to the right of 1, negative to the left. I am multiplying those, so if I multiply 2 negative numbers, I'm going to get a positive number. A positive and a negative number will give me a negative product, and 2 positives are going to give me a positive. We want greater than 0. We want a positive interval. And here is our positive interval, and here is our positive interval, which means that we are looking from the negative infinity to 1, and we're looking at the 2 off to infinity. But keep in mind, that was our x values, and we only have a limited space for our wire and our sides over here. If we come back using those critical key values, that 1 and that 2, and let me switch colors over here because we got a lot going on here. I have that 4x and 4y, so I need to come back over here and using my 4x and my 4y there. And so I am really looking at if my x is my 1, then I'm going to have my, here, let me come up here, make my little wire here. So my 2 pieces are either going to be my 4, right? I'm either going to have a 4 and an 8, or I'm going to have an 8 and a 4. Whether I'm plugging in my 1 or I'm plugging in my 2 as my 2 critical key numbers. But also, I know that I only had a wire that was 12 centimeters long, so I cannot go off to a positive infinity and I cannot go off to a negative infinity. So my intervals that I would have would be the 0, whoops, wrong pen, my 0 to 4, and my 8 to 12 as my final answer there. And I'm going to let you guys play around with 12, and I'm going to let you guys finish up on 11.